In today's episode, let's talk about an academic paper that my friend Anne sent me. And this is a fascinating paper. The paper's title is called Do Efficient Transformers Really Save Computation by Kai Yang, Jan Ackerman, et al. And this is from February 2024. This is a preprint, so it has not been peer reviewed yet. But one of the things this paper talks about is how efficient transformers are and the trade-off of efficiency versus problem-solving capabilities. The net of the paper is this: model sizes and problem-solving capabilities are essentially a correlated relationship. They go hand in hand. The bigger a model's capabilities, the more complex problems it can solve. The smaller its size, the fewer capabilities it can bring to the table. You would think this is not something that needs to be studied, but it does, because there are always weird twists and turns when it comes to computer science, particularly artificial intelligence. So it's good to have this confirmation of how model size affects its problem-solving capabilities. Where this gets interesting, it's not in the paper itself, but model size, one of the proxies for understanding model size and model capability is something called context window. Context window is essentially the short-term memory of a generative model, of a large language model. Early models like GPT-2, which came out in 2020, had a context window of 1,024 tokens. This is approximately 700 words. You could have it do some writing, but its short-term memory was the last 700 words in the interaction with the model, and everything that happened after that, the early stuff just gets forgotten. The free version of ChatGPT today can handle, several thousand words at a time. And you've probably noticed, if you use the free version of many models, they get forgetful real fast because their context windows are so small. And that's obviously because they want you to pay for the bigger models. The bigger models today, the paid ones, have context windows in like the 25,000 word range, where now you're talking lengthy conversations, right? If you think about it, this book here, Anne Handley's Everybody Writes, is about 75,000 words. So a third of it can fit in today's models pretty comfortably, at least, things like Llama 2, etc. The paid versions of ChatGPT, of Claude, of Google's Gemini, they can handle substantially more. GPT-4, the current version Turbo, can handle 90,000 words. So the entire book can go into working memory now. Claude 3 Opus, which just came out not too long ago, Google Gemini 1.5, which is around the corner, and presumably GPT either 4.5 or 5, will have context windows in the million token range, or about 700,000 words. What this means in terms of their short-term memory is that the bigger their short-term memory, the more complex problems they can solve, because you need to load that much more information about complex tasks so that they have time and space to think and not lose track of what they were thinking about, not lose their train of thought. Just like you and me, right? If we have a particularly complex problem, we have to break it down into pieces, try and solve the individual pieces and glue it back together. We cannot, except for some savants, we cannot, for the most part, do it all in our heads immediately. Someone gives you a fluid dynamics equation. You have to write that stuff down and work through it step by step to get to an answer if you want the answer to be even remotely correct. So we need that space mentally. AI models do too. AI models need that space to be able to process, to be able to think. And the more space they have in their short-term memory, the better they perform, and the more complex tasks they can perform. What this means is we are probably within the calendar year, it's 2024 as I record this, within the calendar year, we're probably going to look at models that have that million token memory. So we're going to go from 90,000 words in a working memory to 700,000 words within the year. That adding a zero and then some to their capabilities means you add a zero to their kinds of problems they can address, because they can remember more and they have that ability to deal with more complex problems, to take more time, more space to solve problems. What does that mean? If we talk about AI and the future of work, that means that more tasks are on the table. combined with agent networks, which is essentially models working together to solve more complex problems than any one individual model can do by itself, fact-checking each other. Agent networks and very large context model windows will mean more tasks that are traditionally done by humans today will be capable of being done by machines by the end of this year. So if you think about the challenges, say, of arguing a court case and how much case law you would have to have in working memory to be able to successfully argue. Well, today, 90,000 words, that's a decent sized book. How much case law is 700,000 words? And can a machine process that effectively? They soon will be able to. And so more tasks, say in that legal domain, will be available for machines to help solve. So this paper, I think it's worth reading if you enjoy the mathematics of it and you want to get a sense of what it was that the researchers were testing. But the key takeaway is that model size correlates with problem-solving ability, and we are about to have a very large jump in problem-solving ability very soon. And so we need to be prepared for the implications of that and what it means and how it's going to impact our use of generative AI and how generative AI will impact our interactions with it and what it can do that we don't need to do anymore. So that's the show for today. Thanks for tuning in. Talk to you soon. If you enjoyed this video, please hit the like button. Subscribe to my channel if you haven't already. And if you want to know when new videos are available, hit the bell button to be notified as soon as new content is live.